Welcome to Reliability Matters, a podcast for the electronic assembly industry. Each episode covers topics related to reliability, best practices, and environmentally responsible assembly techniques, with insights from experts across the electronic assembly industry. Now, here's your host, Mike Konrad.
Welcome back to another episode of the Reliability Matters podcast. I am, as you saw 2 weeks ago on my last show, I am not in my normal studio. I am in sunny Anaheim, California at the IPC Apex Expo, and I'm in my friend and colleague's booth, Trevor Galbraith from Global SMT Magazine, and he has graciously allowed me to invade his space and produce the show from Anaheim at the Apex Expo. Thanks to Summer and Jen for pushing buttons behind the scenes, making sure the cameras are on, making us look absolutely the best we can. I appreciate all of your effort. My guest for this portion of the broadcast is Greg Beck. He's a director of sales for Absolute Exhibits. Welcome, Greg.
Thank you very much. It's Absolute EMS.
Absolute EMS. You're right.
That's okay.
You know why I said that? We were working with an exhibit company called Absolute Exhibits.
Oh, that'll stick
and I'm
in your
here at
head.
the show, and I think that just stuck in my head. But thank you for that correction.
No problem.
It is Absolute EMS. Yes. Absolutely not exhibits. Yes, there we go. Just to be clear. So many industries, Greg, require strict adherence to quality standards, obviously. Yep. You know, we have standards, we have IPC standards, we have ISO, AS 9100, et cetera, et cetera. What should OEMs, what should potential customers of yours look for in a contract manufacturer to ensure that they meet or exceed those quality benchmarks?
Well, the ISO procedures generally refer to general industry or medical, like 1345 for medical. But beyond that, they really should look for documentation control, quality control, of course, but traceability, track and trace for components, PCB board level or sub-panel level will help with any kind of future issues that may relate to recalls or anything like that. And of course, aerospace customers, there's the basic AS 9100 for aerospace and mill, but now there's also addendums for like space qualified stuff. We have a few satellite customers and they call out a little more than just AS 9100.
Yeah. It's AS 9100 on steroids. Yeah,
pretty much.
Yeah. It turns out, I think we learned it with the Hubble telescope when they realized they installed a mirror, backwards or something. They had to go up and fix it. Costs a lot of money to go up and fix a telescope or any kind of satellite.
Yeah, and with satellites, it's almost impossible.
Right.
Yeah.
So it's like you got one shot at it. No pressure, just one shot.
No shot.
What are the most critical reliability tests contract manufacturers or customers should perform to ensure long-term performance, and how does all that help prevent field failures? So
cleanliness is obviously the primary concern because we're worried about corrosion long-term or dendritic growth as potential problems, especially if it's a lead-free product. We also have a lot of customers for high reliability that want to do conformal coating. So we actually do extra cleaning and testing before we conformal coat boards. And then we also do cleaning and testing after conformal coating. Because if there's anything trapped underneath that coating, that could be a potential problem long-term.
So several years ago, I was hired as a court-appointed expert witness in a civil litigation matter. There were two sides. There was the OEM and there was the contract manufacturer. I was on your side. And okay. By the way, it was not Absolute EMS. No. It was a company that shall not be named. And they were given a statement of work by the OEM, who was very anxious to get this product out on the market. And they were backed by venture capitalists who were equally anxious to get a return on their money. So they pushed. And the statement of work was the worst statement of work I've ever read. And I'll give you an example. They wanted the CM to also acquire the boards and get the boards fabricated. On the type of board material, I quote, "Down and dirty FR4, nothing special." Okay? What is that? Just imagine what that tells you about the rest of the statement of work, right? If the down and dirty, nothing.
I've got an idea.
Yeah. And I'm thinking, I don't even think that's a slash sheet, in the IPC world. So anyway, long story short, or shorter, they were given a horrible statement of work. They followed that statement of work. They thought that they had covered themselves by warning the customer, this is not best practice. The customer said, do it anyway. The boards failed. Big giant recall, big giant lawsuit, big giant legal fees, hiring experts on both sides. And it turned out that what the CM learned is sometimes the word no is way more profitable than the word yes. How, without throwing any of your customers under the bus, you want to satisfy your customer. You also want to make sure that you build a product that works. Sometimes the way they want it done or the design of the board or something does not add up to a reliable product. How do you work with your customers, look at what they want, understand what kind of questions do you ask them to ensure that you're able to build it in the most best practice method and ensure the longest term reliability, even if that means not doing what they originally asked? How do you work with them? What kind of questions do you ask?
Well, there's a line of demarcation between OEMs and contract manufacturers. Us, Absolute EMS, is a contract manufacturer. We do no design work. So when we build product, we will warranty the workmanship, 100% stand behind that. And that part of that includes the specifications, like you mentioned, that are sometimes a little vague or they're incomplete. So we will go back, if we see any questions at all with the specifications, we'll go back to them and ask them exactly what they're looking for. And if they don't know what they're looking for and we make a suggestion, we ask them to accept the responsibility for that. So that makes that demarcation line pretty clear. So if there is something that is a form, fit, or function problem with the end product, that is clearly with the OEM, versus if there's something with workmanship that, say, we didn't do to a specification we called out or they called out, but we agreed to it, then that would be our responsibility.
Yeah. It's I find that the more collaboration that industries like yours have with industries like mine, the better for everybody.
And
right?
the earlier the collaboration, the better.
Right.
So if a customer can come to us with a preliminary bill of materials, we can identify some long lead time parts, or if there's any issues with a special nozzle for BGA insertion or something like that, we can get that going and talk to them about those type of things.
Yeah, excellent. Today's world of electronics, I don't need to tell you this, is miniaturized, highly miniaturized. In fact, I think things just got smaller in the last few minutes, right? And miniaturization brings lots of challenges.
Yep.
I'm in the cleaning world. So when you talked about, cleaning and testing, you warmed my heart, because that's our world. But in terms of miniaturization, that falls on placement, that falls on printing, that falls on testing, that falls on cleaning. It just makes everything more difficult. How has miniaturization landed in your world, and what are the challenges and ways to overcome those challenges that you have to deal with now?
So we definitely see that right now. We are currently able to do 008, 004 component placements. Those are 0.5 millimeter by 1/8 millimeter. You cannot see them without a microscope or a magnifying lens.
Right.
And if you go like this with them on your hand, they just blow off. So we have all Hanwha pick and place equipment. We're actually their center of excellence for North America. And we're able to place 008, 004s. And we're already aware that next down the line from that is 006, 003 components, which sound like, why would anybody need something that small? But for swap applications where size and weight are critical, like with drone use now, every ounce of weight is a minute of drone time up in the air. So if they can shave sub-millimeters or sub-grams of weight off, it's going to help them with their performance. So we are seeing that, along with AI customers who want to put caps in between ball grid array pads and things like that.
And finally, who's your perfect customer? Meaning, are you a prototype shop? Are you a high production volume shop? Do you have a certain niche that you just love to work in, that you're really good at? What's ideal?
Yeah, in general, we are a low volume, high mix shop, but we focus on OEMs that have medium to high complexity product and need very reliable product, whether they're asking for a build of 10 each, say for NPI, or we do runs as high as 5 or 10,000. It's whatever they need for high reliability and high technology. That's where we fit in the best.
And what part of the world are you in?
We are in the center of Silicon Valley in Santa Clara. So we have lots of
it, man.
We have lots of AI customers right around us, GPU customers right around us, and a lot of aerospace customers up and down the West Coast.
Yeah, very good. Well, Greg Beck, Director of Sales at Absolute EMS, thank you for being my guest today, and I appreciate you being here, and let's talk again when we have more time.
Love to. Thank you very much for inviting us.
You bet. And welcome back to this segment of Reliability Matters. I appreciate you still being here. My guest for this small section of the show is Brian Watson. He's the co-founder of HyRel Technologies, a global provider of quick-turn semiconductor modification solutions. Just that brief description just opens up a whole bunch of questions in my head, Brian.
Of course.
Thanks for being here.
It's a wide bandwidth.
It's a wide bandwidth.
Yes.
It covers a lot of stuff in this very short time that we have. You describe your company as a provider of high-quality quick-turn semiconductor modifications.
Yes.
That's the word that's sticking in my head. Modification solutions serving the military, space, automotive, energy, and commercial markets. And you basically serve companies seeking to improve product reliability.
Yes.
So you had me at reliability.
I had you reliability.
And you confused me at modification. So
Right.
what type of modifications to semiconductors improve reliability? Why aren't they just built that way?
Right.
And why did they do it one way and then you have to take it and make it better? And why do they require modifications in the first place?
Sure.
Probably not the first time you've heard that question.
Probably not the first, right? The component modification industry is very, very narrow. Okay. There are literally 4 of us in this market space, right? Wow. Jabil last year acquired one of the other ones. That was the 5th one, so that they could do their high reliability modification services for themselves, right? And so what that is really, we have the Europeans to thank for this industry, right? In 2005 with the lead-free initiative and ROS, tin whiskers have been around since the early 60s.
Yeah.
Yeah. So from the gold mitigation and then converting from ROS to tin lead, that's what creates the reliable product. Now, the processes involved with that and to do it right, they're evolving. In 1998, when NavC came out with the Raytheon, as well as Corfin Industries, the original Corfin machine was a great machine. That was 1998. And as we continue to evolve, right, the XY gantry machines aren't capable of doing the mix of components that we touch. And we touch a very high mix of components. I mean, from 50 by 50 pin grid arrays to the reballing side, to 0201s, to connectors, headers, we're doing all that. But we've changed and developed new robotic systems. So we have our robotic system is called the VersaCell. We have 8 of them, right? So it's not just a little number here. And, 8 means that we are truly processing robotically. The companies of the 4 companies, right? There's outside of the Micros conglomerate, right? And Tintronics, which has been in business for a long time. We're friends, but everybody else is using these, what I call 6-foot robotic arms, and using this huge arm, if I can get it in there, right? To move an 0201.
Right.
And think about the conundrum of that, right?
Yeah.
6
speck of dust on the end.
It's a speck of dust, right? So we have a very precise micro robot that's good to 5 nanos, right? We created our own fixtures. We took a machine that was 9 feet, and we had a Corfin machine, but the Corfin machine's 9 feet, and we condensed it literally to maybe 30-inch throw. And everything you need to get done is there, right? I mean, from picking the part to preheating it to the proper temperature for reliability to we have custom flux with interchangeable nozzles because, the thing about tinning, I'm giving a presentation at the STAR conference on the challenges of properly tinning. Tinning is...
I'll be there.
Yeah,
Kansas City.
Yeah, Kansas City with good friend Bill Capon.
Yep.
Right? Very excited.
Teaching a professional development course the day before.
Very good.
And
Yeah.
looking forward to seeing you and hearing longer version of you there.
A longer version, but looking forward to it. I mean, our first machine was, on a 8x4 Mel's Groit isolation table, right? So we don't have any vibration, right? But if you think about the wide mix of parts, right? One type of machine, especially the XY gantry systems, right, will not do all the parts, right? And what they do is by the time that they've traveled this way and up and down, it's not 9 feet of travel or 18 feet of travel. You're talking 27 feet of travel. And that's time, right?
Yeah.
So for reliability, we have to be able to dial our process to every part, and that's really the secret to having the success to it.
Yeah. On a slightly different subject, you and I first met a little over a year ago in Peoria, not Illinois.
Arizona.
Playing in Peoria. We were playing in Peoria in Arizona, and it was at the UHDI conference, the ultra high density interconnect conference.
Yes.
And it seems to be, a very hot topic right now because our industry has this horrible habit of we're so siloed.
Right.
So the board designers, the software coders, the component designers, the semiconductor foundries,
we are not talking to each other.
Yes. So
and they need to talk to each other.
We are villages along a river.
Yes.
And their boat comes by our village and hands off the latest technology.
Right.
And then the first thing we do is we look at it and they go, well, what the hell do we do with this?
And even how can you build BGAs?
It's like, hey, you realize, guys, that all the soldering connections are underneath.
Yes.
How do we...
Yeah,
and how do we inspect it? How do we stop voiding? How do we,
And to that point, as BGAs continue to go into micro miniature mode, right? There comes a point where, from the TID mitigation point, right, the parts as they're constructed aren't designed to be reballed.
Right.
They never wanted this stuff to come off.
That was never part of their intent.
It was never part of the discussion at all, right? So the problem is getting through to the actual contract houses, right? That because the sphere size is smaller than 0201, you're going to be able to paste it over.
Yeah.
Now, is there a break at 10, 12, 14,000 spheres and up? Of course, there is. But when you get into the 10 range and down, into the 0.35 mil, 0.25 mil, right, 0.2, a perfect example, a customer sends you parts to be reballed, right? And you just go back, I can't do these.
Right.
Because the minute I touch them, I'm taking something off.
Sure.
Yeah.
Sure.
Yeah.
Where do you think we're going with ultra high density? It used to just be high density interconnects. Now they're ultra high density.
Right.
What's after ultra?
Maxi.
Mega high density.
Mega high density.
Yeah. I mean, it's to the point. And I think every generation of engineer has experienced what we're just saying.
Yes.
It's not going to get any, it's going to get more harder. It's going to get more difficult. It's going to get impossible to build. And then we figure it out.
Right? And they thought that they could replace ROS, right, with a material that would not be tin whiskers. Good luck with that.
Yeah.
Because the bottom line is the only way that happens is if we find another element.
Right. So we got to reprint the whole periodic table now.
Yeah. Right. So, we're stuck with this, right? Our reliability side is crucial because when we talked before, lead times in our internship programs were very key to everything. I will say to all my competitors, the day you can do 3 to 5 day turns, let's talk. Let's talk, because that's how, I got started in this industry with John Kerr out of Boeing and writing the specs for this industry. He was my mentor. Huh. And, what's been great is even though he's been retired for 15 years, he's had a huge part in how our robotic system comes up, right? This is how we went past from looking at like an RPS type system. This is how we went past looking past the 6-foot robotic arms. It was his Mensa mindset, right? I did the work with my partners, right? But his Mensa mindset could just dial everything up. right? He's one of those, you'll never hear or anything. Maybe a long pause before a complete sentence.
Contemplation.
Right?
Yeah.
Yes, contemplation. But, from reliability side, my industry is just fat, dumb, and happy, right? It's 6-week lead time, and take it or leave it. We don't care.
Yeah.
And these are the things that will cause failures at some point, right?
Yeah. It sounds like a little too complacent.
Yes. Very
You
complacent.
almost need that challenge of something that can't be done just showing up on your doorstep.
Yeah. I mean,
from the village upstream.
I built one company up to, 7M and 60 some employees and left for a lot of really good reasons. And I got to say, I'm having more fun than I had in my last 10 years at the other company.
That's great.
So-
Well, speaking of fun, it's been fun talking to you. I'm sorry it's a short episode, but I would love to do it again. Let's get you on the show and
Okay.
let's do a full hour and let's go
do
down that rabbit hole.
Great. Sounds
All right.
great. Thank you.
Thank you.
Yes.
Great to meet you.
Yes.
Continued good luck in your business, and we will be back in just a moment. And welcome back for our third and final segment for this episode of the Reliability Matters podcast. Once again, as a reminder, if you're just jumping on, I am not in my normal studio. I'm in sunny Anaheim, California, in the Global SMT Magazine's booth. Thanks to my friend and colleague, Trevor Galbraith, for loaning us this space, letting me interlope into his world. And thanks to our talented team of fine technicians over there running the show. Thank you. I appreciate all the work you guys are doing. And thank you, most importantly. And thank you. My guest is Keith Sweatman. He's the technical advisor for Nihon Superior. Welcome, Keith.
Yeah. Hello.
Glad you're here.
Yeah. Okay. I guess you're looking for some perspective that we're getting on the industry from our position as a.
Well, let's start there. So obviously you're a manufacturer of soldering materials.
That's right.
And what there's a lot of changes. There's always a lot of changes in our industry. It changed since we just started talking, I'm sure.
That's right.
Miniaturization is a huge thing. All sorts of things. I don't want to. You're the expert on it, but what are you seeing in terms of strategic changes, in terms of technical changes? What are you in the middle of figuring out right now?
Well, there's a few interesting things going on at the moment. One is the impact of raw material costs. Now, people will know that some years ago, the industry decided that an alloy called SAC 305 would be the answer to all their prayers for lead-free. Has a bit of interesting history, but it's got 3% silver in it. And although that was tolerable in the early days, it's forcing people to look at whether they're getting value for money for that 3% silver. The other alloy that was always a competitor for the SAC 305 was the Nihon Superior alloy SN100C, which has the blessing of being silver-free. And we're finding that a major part of our business at the moment, and a trend in the industry in general, is replacing a high silver content solder with a silver-free solder. And people are finding it works. Say in wave soldering, you might have to tweak the settings a little bit, but once you've done that, it's fine. And people are left wondering why they ever bothered paying for silver in any case.
Well, I know that there were a lot of, I'm in the cleaning world, right?
Yep.
So contamination, electrochemical migration prevention, well, that's a space I work in. And I know there was some high profile cases where boards suffered from dendritic growth and parasitic electrical leakage, all these ECM related issues. And a lot of those were silver-based paste. They just love to grow dendrites, right, under the right conditions.
Yeah.
So taking silver out not only reduces the financial cost, because it's one of your more expensive pieces of metal, but in many respects, it from at least an ECM standpoint, it makes it a little bit more tolerable to harsh environments.
Yeah. Well,
Is that a correct interpretation, do you think?
Well, yeah.
Close enough?
There's silver was added initially to lower the melting point a little bit. When people moved from tin lead, they were very scared of high melting points. Anything that would reduce the melting point was good. But then they found it had what looked like a good strengthening effect, which it does temporarily, but it gets the strengthening effect from this silver tin into metallic precipitate, which works very well when the solder is fresh. and the particles are small and the spacing is narrow. But you find, and this has been proved by studies, say at Auburn University, that that strengthening effect fades. And so once the solders settle in, the difference between it and a silver-free alloy has sort of disappeared. So I don't want to go on about it too much, but it's an issue that people are questioning the raw materials that they're having to buy to achieve the reliable electronic assembly they needed. The other thing, of course, is the move to low temperatures, because at least in some countries, reducing carbon emissions is still a big deal. Mm-hmm. And it's been well established that by moving from a conventional lead-free solder to a low melting point solder, you can save, some people say 25, some 35% in energy consumption, which gets you points in some countries.
Right. Yeah.
And so the industry's been, keen to see if this is feasible. There was a lot of skepticism because the alloys contain bismuth, and bismuth has a reputation for being brittle. But we found that, okay, if you hit a lump of bismuth with a hammer, it will shatter like glass. But a little bit in solder, it can be surprisingly ductile. But we've found in university studies that it can accommodate strain not by the usual dislocation movement, but by recrystallization. And we can get, at reasonable strain rates, a tin bismuth alloy can be more ductile than the tin silver copper alloy. So people are now feeling more comfortable that they can make this step to a lower temperature solder and a cheaper solder without compromising reliability. Of course, it's just got a bit of a shock if you've been following metal prices. The price of bismuth has suddenly gone up because the Chinese are very keen to secure the supplies. But the basic technology there is that you can make reliable electronics with a low melting point solder.
And speaking of reliable, maybe you can answer this mystery question for me.
Sure.
Most solder material companies, I don't know if your company does this or not, but I've seen so many descriptions of products within a catalog from any particular manufacturer. Sure. They have, solder paste 1, solder paste 2, high reliability solder paste, and then low voiding solder paste. So it makes me wonder, if there's a solder paste marketed as a high reliability solder paste, what does that mean the rest of them are? Clearly, they're all reliable, or you wouldn't be selling them, or the market wouldn't sell them. Low voiding solder paste, does that mean that the others are high voiding? Help me understand why anyone would use anything other than a high reliability solder paste. Is a lot of that just like the marketing department's hand
there
in the pot?
Two things. You're talking about issues like voiding and whatever. That's more to do with the flux chemistry.
Okay.
Usually when people talk about reliability, it's the alloy composition that is used in the solder. And this became an issue maybe 20 years ago when the automotive industry was realizing that solder is being used in conditions where it wasn't used before. Like in an automobile where you get temperature extremes, you get vibration, you get all sorts of things. So that the basic lead-free solder at that time, SAC 305, really wasn't delivering. And so you start to add things to that basic formulation. You add nickel, you add antimony, you add bismuth. You juice the alloy up so that it delivers much higher performance in thermal cycling and shock and things like that. So hopefully when people talk about high reliability, they're saying this solder paste is made with an alloy that has been formulated to metallurgical principles that mean it performs longer in thermal cycling, et cetera, et cetera. So that's the alloy itself. Then, of course, you turn it into a powder, you make it into solder paste, you reflow it. There are other factors that come into play, like voiding, like wetting, like spread. So I think, you've got to give the solder makers are very hardworking people. It's a very tough business. They invest a lot of time and money to deliver the best possible results. So when someone claims high reliability, they will certainly be able to refer you to the testing they've done to address the issues that maybe compromise reliability.
Right.
Yeah.
Interesting. How has you talked about automotive as an example? I have a theory about Internet of Things, IoT. It's the process of putting electronics inside things that don't need them. No one asked for them, but we do it because we can, and they can charge a few extra bucks for it. Now, I'm over exaggerating that, but goodness, you can buy an electronic toothbrush that is connected to the cloud, that has accelerometers and timers, and it'll write a report that little Janie or Johnny didn't brush their teeth. We can probably live without that. But the point I'm making, though, is there's so many, because it's just surely possible, there's so many electronic products going into harsh environments. You mentioned automobiles, wearables, implantables, refrigerators with camera systems inside, toothbrushes with connections to the cloud. How does that impact the fact that so many electronics now, and particularly class 1 device electronics that aren't built to class 3 standards, higher standards, how is the migration, the steady migration, immigration of electronics going into these very consumer, very unfriendly devices, how is that landing in the soldering materials world?
Well, yeah, look, I agree with you that there's maybe excessive use of these capabilities. I mean, do we really need to look at our iPhone to find out whether our refrigerator's working,
Right.
But IoT, don't badmouth that, because in the manufacturing processes, it is making a big difference, because every machine these days will have its website. It'll be, radio, internet connection. So they can be all talking to each other. And you can optimize your line. If each stage of the process is communicating with the next stage, you can have a more efficient line. So there are places where IoT is an unnecessary luxury, and there are places where it's reducing the cost of manufacture and increasing reliability.
Yeah.
So, pros and
Both
cons.
ends. Yeah, both ends of the spectrum there.
Yeah. Just, you're talking about general trends. A trend that gave me a bit of a wake-up call recently was the increased use of jetting of solder paste instead of printing it. That's been the traditional method ever since we had the trauma of introducing solder paste when surface mount technology came in. And stencil printing has sort of become the norm. But it's if you've got a low volume, high mix product, and you want to change from one to the other, you can do it far more quickly with jetting, And so we're working with one of the leading suppliers of jetting systems to supply the solder paste that will work it's a very demanding process.
Yeah.
You've got to get the solder through a tiny nozzle at some incredible speed, and every dot has to be perfect. Yeah. So it's an example of how the industry is responding to changing demands. Is
jetting still limited to, a narrower range of powder sizes and things like that?
Yeah, well, we're going down to a D7 powder size, yes. It depends how big the deposit needs to be, but at the extreme end, it's getting down to those levels. Yeah. But, surprisingly, the industry has responded, and there are products available and being used,
Yeah. We have to wrap up. We're almost out of time. But last question, how has miniaturization landed in your world?
Miniaturization? Well,
Is that affected?
I just mentioned jetting.
Yeah.
Yeah, so that's a classic case where the stencil printing can no longer do it.
Right.
Because of miniaturization.
Right.
Those little dots, they're so close together and they're so tiny.
You can only
if
cut
you just
a hole in
wanted
the
one
stencil so
example
far,
of what miniaturization has done, that the methods that you're using have to be miniaturized as well. So, interesting world.
Interesting world. Well, I really appreciate you being here, Keith. Thanks for stepping in at the last minute. Thanks for being voluntold. I do appreciate you being here, and I'll look forward to talking to you maybe on another episode where we can spend more time and go down a deep rabbit hole.
Sure. Anytime. Yeah, those rabbit holes are getting very deep.
Yes. Let me wrap up here. To my audience, thank you for being part of this episode of the Reliability Matters podcast. If you would like to get more information on any of my guests, including my friend Keith here, my new friend Keith here from Nihon Superior, information about the companies will be in the show notes. If you're watching this on YouTube, look down, click show more, and you'll see where that information is. If you're listening to this on your favorite podcast app, just look at the show notes and you'll see contact information for the companies that I have been talking to today and on the other episodes forthcoming. I really appreciate you being here. Until I see you again, keep doing it right, keep learning, and remember, reliability matters. I'll see you again in 2 weeks.
Thanks for listening to the Reliability Matters podcast. Join us on the second and fourth Tuesday of each month for new episodes of Reliability Matters.